In this video, we are going to be looking at structural rearrangements present in the CUP1 region of the yeast genome. Just as a reminder, the CUP1 gene is a copper metallothionein gene. In other words, this gene helps the yeast to survive in the presence of copper and other heavy metals. In general, the more copies of the CUP1 gene a yeast accession has in its genome, the better it will be at surviving under these conditions. We are going to be comparing our PGGB graph of the CUP1 region to the gene-based schematic created by the Yeast Population Reference Panel, YPRP, for the same region. Our graph is in the upper right-hand corner and has the CUP1 gene highlighted in blue and the YHR054C gene highlighted in green. The schematic is in the bottom left. Because Bandage lays out the graph differently each time, your graph may look a little bit different. We will start with SK1, which has the simplest structure in this region. It has one of each gene marked by the orange oval on the diagram. On the graph, SK1's path is marked in blue. Coming from the 5' direction, right to left on the diagram, there is a YHR054C gene followed by a CUP1 gene. On the graph, the 5' path comes from the upper right. Then it takes in this green loop, capturing its one YHR054C gene, and then as it exits, it captures its one CUP1 gene, matching the diagram below. Now let's look at Y12. It's a little more complicated. As you can see in the diagram down below, it has 4 copies of YHR054C and 7 copies of CUP1. The YHR054C genes are interspersed by either 1 or 2 copies of CUP1. The Y12 path was highlighted in yellow in Bandage, and you can see it's capturing one of those large loops, but skipping the other one. Coming in from the 5' direction, the path comes into this green loop, capturing its first YHR054C gene. We are moving from right to left on the diagram below, so we then expect to have a single CUP1 gene, and we do. After that, we have a YHR054C gene followed by 2 CUP genes, and again, and again. Now we follow the yellow path down toward the exit, and exit out, capturing our last CUP1 gene. And finally, let's look at S288C. Its path is shown in pink. Looking down at the diagram below, you can see that there are 11 copies of each of the genes, and they are arranged in alternating format. Coming down from the 5' end, S288C takes a different path than the other two. It comes and captures this loop here, capturing its first combination of YHR054C and CUP1. After that, it takes in this loop, capturing another YHR054C gene, and then you can see it continues on in alternate format, going through both of the loops and coming back to where we started. At this point, the S288C path actually goes through this green loop again. At that point, it exits the loop, capturing the last CUP1 gene. As you have probably realized, it's not always easy to trace a path through the graph, even if that path is highlighted. So here are a few tips. Bandage will allow you to show the node names, and then you can use those to compare to the paths that are in the GFA file. We are going to use the S288C CUP1 region, and specifically the region in the circle. As you recall, the green loop is the loop that S288C goes through twice. So we're going to try and confirm that. The bandage picture on the left is a blow-up of the region, showing the node names. To show the node names in Bandage, go under the node labels on the left-hand side and click on Name. In the module, we show you how to pull out the node order for each of the paths. On the right-hand side, I have 2 subpaths that are relevant to this region. On the Bandage picture is the path for the first time that the S288C path goes through that green loop. Let's confirm that it's correct. We'll focus on the big nodes because they're easy to see. So 7646 is on the bottom of that column of nodes. And as we move up that nodes, we hit 7641 just before the gray region. And then coming around, we can see within the gray region is 7634 and 7625. Going out of the region, we hit 7604, which is up at the top of that column of nodes. The nodes highlighted in gray are the nodes that encompass that green loop that S288C goes through twice. When we look at the numbers in that first stack, everything looks like it's in order and going the right way. but when we look at the second stack, we have a group of nodes in the 7600s that's plopped down in between nodes in the 7300s. So let's look at that and see if that's correct. So now I'm showing the path for the second time that the S288C path goes through the green node. And so it's gone through both of the loops and come back down, and it's about to exit. So coming into this snarl, you can see node 7391 and 7371 on the diagram to the left. In the node stack on the right, you can see that those are near the bottom of the stack, going upward. Then we go into the green loop. Those are both in the gray portion of the right-hand node stack. And finally, we exit the loop and hit node 7361, and that again is on the right-hand node stack, right above the gray portion. And so everything looks like it's actually going in the correct direction. One thing to note is that we're actually missing a couple nodes in the gray region the second time we go through the graph. But by and large, we're hitting most of the nodes in that region twice as we go through the graph. By comparing the order of the nodes in the bandage file to the order of the nodes in the path lines of the GFA file, we were able to confirm that the paths that we traced through this complicated region were correct.